the whole concept of what we're doing is turning downlights on their heads. And hopefully you'll get the point of the pun of the semi-revolutionary concept for recessed lighting. It's going to become obvious during the presentation. So before we get started on that, a brief history of light and lighting. We all talk a little bit about how Edison's bulb has never been changed since its introduction over 100 years ago. And the same actually holds true for most luminaires. So we have downlights, and this is an early patent of a downlight from 1939. So most downlights still look the same as they did 80 years ago. So that is kind of the state of the history of the industry. Now, when we got into solid state lighting and when we got into LEDs, the fixtures started evolving a little bit, and the evolution went kind of from more of the same, and pretty much it was, we have a T5 fixture and we need to convert that to an LED fixture, and everybody just took the T5 and the sockets out and stuck a piece of board with LEDs on it, and now we have a brand new fixture in place. And we did the same thing with incandescents, and we did the same thing with a number of other fixtures. But basically, we went from more of the same to then a little bit into this whole thing. People started doing some really cool and creative stuff. Some new shapes, some new technologies, some new adjustability features within the luminaires, not only in terms of the tuning of the luminaire, but also on how the luminaire fits within the space and what the luminaire does in where it's installed. So it kind of started getting fun. And from that, we go to a picture of my wife. So first rules, remember this is Vegas, and what happens in Vegas stays in Vegas. So you can't tell my wife, if you ever meet her, that I actually use her picture in my presentations. Okay, everybody cool with that? Okay, good. So my wife and I went on a holiday in Peru. This is actually in the city of Cusco, right before we went to Machu Picchu, and this is 3 years ago. And it's wonderful because she really loves to pose for my pictures. What she doesn't realize is that I'm actually taking pictures of the luminaires behind her instead of her. So please, again, don't tell her this. But the point that I'm trying to make with this is that some people should actually be fired for some of this getting cool and creative with what they do. If you look at this, this is a beautiful street light lamp on a pedestal on this fantastic colonial city. I mean, this is a UNESCO World Heritage Site that it's illuminated perfectly 50, 60, 80 years ago. And somebody decided that it was a cool idea to replace their street lights with this. Okay, so in my world, I guess I'm not allowed to say that they should be shot, but, oops, sorry. But somebody should be fired for doing something like that. So it is cool to go from more of the same to really cool and creative, but we have to keep a balance into what it is that we do and how we do it and how we evolve into that next generation of what we're going to do. And that's kind of what we're going to talk about today. How do we go from more of the same to beyond cool and creative? And we want to be cool and creative, but we also want to solve glare. And again, also question for everybody. How many of you were at the opening session this morning, at the keynotes? Everybody. So everybody heard Bob and everybody heard Nancy Clanton as well. Excellent. Perfect. So first of all, let's understand glare a little bit. Glare is usually categorized in two different groups. There is disability glare. It's when you're driving and the headlamps from the car in front of you actually coming in the other direction blinds you, and then you can't really do what you were supposed to be doing. That is called disability glare. And then there is discomfort glare, which the IES actually describes as a sensation of annoyance or pain caused by high luminance in the field of view. And there's three main components to this type of glare. Basically, the luminance of the glare source, and we know that this is an issue because we keep making better and better LEDs, and by better and better, I mean we're putting more and more light out into smaller and smaller packages. The position of the source in the field of view, and we'll get the next slide actually covers that, where that fixture is that we're looking at from where we're standing, and the luminance of the background, right? So there is a way of measuring that glare, and there is a rating called the Unified Glare Rating, UGR. How many people here have heard of UGR? Okay, everybody has. How many people understand UGR? Okay, that's good, that's excellent. So in a nutshell, basically the formula, what it does is where is that brightness projecting into what we are looking at. So there are some limitations to the formula as well. Basically, it is limited to situations where the solid angle is from 0.0003 to 0.1 steradians. So in this example, if we have a 2x4 troffer installed up in the ceiling in a place that it's 3 meters, so 10 feet and 9 meters along, and we have our server here, basically that solid angle, that 2x4 is going to be shown as 0.003 steradians. So you get the idea of how this is going to work. So to get from that to why is UGR all of a sudden really an important thing? In Europe, UGR has been in use for the longest time. Since '95 that it was introduced, everybody looks at this and it is kind of the way that they design their spaces. In North America, we have some standards, and what we have done in the past, because we used to have many, many moons ago, a thing called VCP, Visual Comfort Probability. We don't use that term anymore. But because we didn't have anything different, we actually started doing balances and we started doing ratios in order to measure what the uniformity of the backgrounds were, as well as what the brightness was at certain angles. And there are some standards, RP1, for example, that has a table that says what products actually meet, or not products, but what technology can actually meet that standard versus which ones don't. But UGR is a very good measurement. It actually is really good at predicting where that glare is going to come from. Part of the reason why UGR is really all of a sudden very popular is because of new building standards. We used to have leadership in environmental and energy and environmental design, and it was strictly on that, energy and environment, how to make the space that I'm building more energy efficient and more environmentally friendly. The new thing is the well building standard, and well building standard is not only looking at the environment, but it is also looking at the individual within the environment and how we actually build buildings that are healthier for the occupants of the space. And it just so happens that the well building standard actually has a criteria for glare control, and the criteria for glare control can be achieved by different methods. One of them, the simplest one, is basically you don't shoot any light below 90 degrees. So if you use indirect lighting for your interior lighting in your whole project, you're golden. No problem. You're not shooting any light down, you're good. But most people actually prefer some sort of a downlight component combined with an uplight component because it is actually better. We don't feel or like that feeling of gloominess from a fully indirect lighting system. So one of the other avenues of actually meeting that standard is by having a UGR rating of 19 or less if we're on a lower ceiling, or 22 or less if we're on a higher ceiling. So the lower the UGR number, the better it is, the less glary the space is, right? So far, everybody's good? Okay, so what do we do to improve these UGR values? So first things is we have to start introducing some sort of advanced optical control, because no matter how much we keep throwing light out, we have to find a way to control where that light is going so that it's not in the offending zone all the time. So in order to do this, what we do is, we introduce advanced optical control, which is going to decrease the contrast between the luminaire and the adjacent area. So there's going to be a little bit, and I apologize for the pictures, they were not professionally taken, you can see that. Sorry, there we go. So we have a little bit of light bouncing on the surrounding area, which is going to actually decrease that contrast between the source of the light and that. And basically that allows us to balance the uplight and downlight component. And we're trying to remove light, and you can see this on the shadows in here, that we're actually reducing light from the offending angles. So when we look at it kind of in a front view, basically we have a zone right above the fixture where we don't have a lot of brightness. Onto the sides of the fixture, or we want to have a higher brightness zone because we want to illuminate that ceiling, make that area as large as possible, and then have very little or no light coming out of the offending zone, basically between 90 degrees and 45 degrees. And on the direct component, we obviously still want to have a little bit of light coming down in that direction because that is going to help us with that contrast and everything else. So how does this work? So we have our LED sources up at the top, and then we have an incoupling mechanism that we use. Basically what we're doing is we're concentrating all of the light out of the LED into the light guide. So we don't waste any photons at all. All the light is being pushed in here. And then at the end, after it gets transmitted through the light guide, we have an extractor. Now, the extractor can have many different shapes or many different ways of doing things, and it can be partially transmissive, it can be fully reflective, it can be symmetric, it can be asymmetric, it can be pretty much any combination of different ways of actually defining or designing that. And that's going to give us some advantages. Obviously, we're going to have really good optical efficiency because we're capturing all the light here at the start and we're pushing it through. We're mixing that light, and interestingly enough, we didn't plan anything with our previous presenter, but he was talking exactly about some of the same things. Light is distributed optimally in the space, and this is directly related to the application. This is defined by what is it that we're trying to do with the product, what is the application that we're trying to fill, and then we actually design that reflector or that extractor to match that application that we're trying to meet. Obviously, we try to remove luminance from the offending angles. Again, we try to keep this above 90 degrees and try to have some sort of a cutoff angle in here as well, somewhere around that 45 degree. And that helps us also decrease the contrast. So here's an example of a prototype that we built. And all of the shadows in the background are done for illustrating the purpose. We have some light coming out of the extractor, bouncing off the ceiling, creating this illuminated ceiling from a semi-recessed fixture. You can see the light is going up there, and then we have a dark area right around the offending zone, and then we have a certain amount of downlight that is coming straight from the fixture down that balances out with that whole indirect component that we had previously. Then we evolved that a little bit, and so basically we went from linear versions of this material to creating something that was circular, and we're doing exactly the same thing. We have control optics that are actually putting a little bit of light around the area. We're reducing that contrast between what is being extracted right at the edge of the luminaire, right at the extractor zone, and we're basically reducing that contrast. And again, if you look closely here, you can actually see that the shadows are there, that we're trying to not have a lot of light into that offending zone between 90 and 45 degrees. Now, this is kind of if we were talking about revolution and we have a downlight and we turn that downlight 360 degrees, it's still going to be a downlight. It's still going to be shooting light down. But if it's a semi-revolution, we're only rotating that fixture 180 degrees, and now we have some of that light actually shooting up into the ceiling, and that's what's helping us. Right? So I'm going to try this. There's a video here. See if that works. No.
You might need to hit return.
Yeah, I think we do it over here. So one of the things that we have done is we've actually kind of decided, let's play a little bit with this, and we broke the prototype of the luminaire into 4 different segments, and we can control those different segments individually of each other. So this adds a number of possibilities as to things that we can do in the future. You can add directionality. For example, imagine that you're in a hallway in a movie theater, and all of a sudden you want to tell people, if you're going to the theaters, it's that way, but if you're exiting, it's this way. So you can basically just have kind of like the landing strip at an airport, that you can have all the lights only have the one segment that it's going in that direction turn on at the same time, and then in the opposite direction. Or if you're trying to do any kind of wayfinding or something like that, or even if you want to do artistic stuff where you want to actually play a song and actually have the different sections of the luminaires play along with the music and synchronize depending on what you're doing. There is a lot of possibilities of things that can be done with that. We just wanted to illustrate that there is opportunities to do different things with this type of technology. So the extractor itself is what defines the application, or the application actually defines the extractor. We can have, I don't know how clearly you guys can see this from there. It looked awesome in my presentation when I had it only on my laptop, apparently. I should have looked at it better. But basically we can have a fully asymmetric throw that it's kind of something that you would use for a grazer or a wall washer. We can have mostly indirect. We can have a balanced direct and indirect. We can have mostly direct, or we can have fully direct in here. And you can see that the different extractors basically can have some asymmetry where you're throwing light at a different angle on that side versus what you're throwing in this side, or fully symmetric, or somewhere where you actually have a certain amount of light leaking through the bottom extractor, as well as some light going out through the sides. This is another example of something that we can do, kind of trying to bring the technology into prototypes and into something that could be described as a product. So in here, what we did is this is basically a 1-inch aperture up in the ceiling, and we were able to bring this very, very close to the wall. One of the advantages of doing this is that you're not going to have anybody that's actually going to be standing on the wall looking up to see what's in the fixture, unless they really want to see what's in the fixture. But you're going to avoid glare by doing that, because people are not going to be, or the luminary is never going to be in the field of view of the user. Right? So very small aperture, very close to the wall from the ceiling, and we're able to have some really decent uniformity across that wall. And a very good throw all the way down to the end. And there's no hot spots along the whole area that it's being covered. So some things that can be done with a very, very small fixture, by the way. This is so about 5 inches high by 3 inches by 1 inch aperture. So very small for a long fixture. And then another example of something that can be done the same way. This is just a couple of simulations that we did using AGI and pseudocolors, and we basically downloaded that. This is not intended to trash anybody. This is a product that we downloaded from the internet from one of the top suppliers of wall washers and asymmetric lighting, and we ran a comparison side by side between what we could do with some of this nice advanced optics versus what we could do with their product. And you can see where that distribution is actually throwing the light down. And in here, I just built a little bit of a scale down on the side. And this is about 9 inches, again, from the wall. And we have about better than 8:1 uniformity across the whole plane of the wall. And this is a 9-foot wall, by the way. So it's very nice that close to the wall. And then where this is taking us into the future is, as the technology keeps progressing and as LEDs keep getting better and smaller and they offer more light, this is just for scale. This is 5 centimeters, so about 2 inches here. So we're looking at the thickness of the material going down from, currently it's 9 millimeters for the material. It's going down to about 3 millimeters in the next generation. Which obviously is going to produce some significant savings at the time of manufacturing, because there's a lot less material that it's being used in here. You could be doing 2,000 to 3,000 lumens per foot out of this very small thing. And obviously, if the technology catches up and smaller LEDs come to market, we could potentially actually shrink this even further. So We're looking at a new generation of microluminaires. If you imagine something that can be fully controllable, that can be delivering, 800 lumens in a very small, tiny package that it's, 4 inches by an inch by an inch and a half. So this tiny little puck can actually be installed almost anywhere and provide you with pretty much all the light with a really good control distribution. Something else to keep in mind in here, again, for those that were at Nancy's keynote this morning, is she said, let's move away a little bit from the whole, it's the same form factor that we have. I wear 2 different hats. I work as a lighting designer, but I also consult for manufacturers. I know how hard it is to follow up on that because, yes, there might be a designer or 2 that are going to go all the way for you and say, yeah, you know what? I'm going to use that product and I want to help you design it and it's going to be awesome. But the majority of that development is going to be towards something else because not everybody is going to want to use that really cool, fancy product that you just developed. So there is a balance to be had here in terms of what we can do versus trying to fill all of the existing sockets and all of the existing holes in the ceiling where a standard downlight is sitting right now. So obviously we can play, and some of these things can actually help us create better shapes, different shapes, new things that haven't been done before. All right? So thank you very much for your time, and any questions?
Thank you, Wilson. Do we have time for several questions?
Yeah, I think so. Is this live? Yeah, okay. I've seen that before. It's pretty awesome. So, Wilson, you're a great person to ask, and I hope answer this question. I like to think there's a movement away from downlights in general, meaning can downlights that just illuminate your face and make you look like crap, and a movement towards illuminating vertical surfaces. So, technically, a wall wash is a downlight, but do you see a movement in design where people are like, let's not even use downlights and let's illuminate vertical surfaces?
Well, ideally, that's a great question, and thank you very much for that. Ideally, there's plenty of designers that talk about, the downlights being the zits in the ceiling, right? That's a term that it's used quite often. Like Nancy said this morning, if we can actually just look at what the effect is of what is happening rather than where that light is coming from, that would be where we would all be happy, right? That surface is illuminated, but I really don't know exactly what it's coming from. I just know that it makes me feel good. And there is light coming from the ceiling or the skylight, even though there may not be a skylight in the space. Yes, it'd be great if we could actually move and push this even further to say it's all about the space, it's about the architecture being brought to life, but I think there is a long way before we get there. Yes?
In one of your slides you showed the concept downlight and upside down. Well, I was looking at the ceiling here. I'm not sure how much light we will get doing that. So my question is basically, have you also assessed the type of ceiling and the distance from your luminaire to the ceiling and the impact on the performance?
Thank you. That's also a great question. First of all, it's not going to be a one-size-fits-all solution, right? We know that there are, every time that one of you opens your product catalog, you realize that you have thousands of products that you offer because you have different applications that each one of those products is going to cover. So we have done some analysis on them. We have actually run some simulations for UGR calculations, and we actually have some pretty good numbers below that 19. And in fact, there is a more stringent UGR reading for VDT intensive applications, which is a 16. And in some configurations where actually this type of design will actually meet that and exceed it. you're absolutely right that if we're looking at something like this, you're either going to waste half the light that it's going out of that fixture, or you're going to have to maybe incorporate some sort of secondary or tertiary reflector to have something that not only is catching that light, but it's actually dispersing it over a wider area and then bouncing it back down. It is a, it's a matter of developing the right number of products for the right number of applications. Thank you. Anyone else?
Actually, I have a question. Do you have any, thank you, I generally don't need a microphone. Do you have any licensees currently for this technology?
Actually. Thank you very much, and thank you for asking that question. Did somebody slip you money to ask for that?
Not enough.
Actually, I think in the last week, the technology just was licensed to a large European manufacturer. I'm not sure if I am allowed to disclose. Okay, so Phalo Sylvania, the European version or the European arm of Phalo Sylvania is actually licensed the technology, and they will be releasing, or well, they're hoping to release product within the next few months. I think they're adding them to their Concord line, which is one of their premier lines. Yes. Thank you. Any other questions? Okay. Thank you very much, everybody. Really appreciate you guys being here.